you don't have to write these down because these first three examples that we're going to do were on your quick review of log sheet that we did on Friday. You were supposed to read them, get them done really well, and then do question 1 on the back. I'm just assuming everybody did that, but as a review, I'm going to go over those 3, okay? And now we're solving exponential equations. Exponential equations are equations where the x is in the exponent. And if it was non-calculator, they always appear on your powers chart. But these are calculator questions, and so we're going to develop the technique for solving, which is using your log laws and using logarithms. Because logarithms are inverses of exponents, they solve for exponents. So if you have a question like this, where you can't change the basis to the same thing because 3 is not in your column of your choose chart, you're going to take the log or the natural log or any base log of both sides. So this time I take log of 10. We usually use log or natural log because they're the easiest buttons to find on your calculator. Now if I take the log of both sides, I'm like, hey, I have a log law that lets me bring the exponent out in front. That's the whole power of logs, is they bring exponents out in front, and we want to solve for x. So now this x is in a place where we're used to dealing with x. X times a number equals a number, right? If it was like this, you'd have no problem telling me what to do next. To get x by itself, you'd have to divide by 2. So here, to get x by itself, we need to divide by log of 2. And we get that x is equal to log of 2 divided by log of 3. And we're going to get a decimal for that as an answer. Pull up our calculator. Wait.
Isn't a log of 3 divided by log of 2?
Yeah, it is. I don't know where things are going bad today. Look at that.
1.58.
So we go to our calculator and use the fraction button if you want. Log of 3 divided by log of 2. And push enter and get 1.585 answers to 3 decimal places. And this is the beautiful thing about logarithms and calculator parts of your question. You can guarantee to find out if you're right. You just got your answer. I really like using the store button. I like to store my answer as x. So now I have that x is equal to 1.58. What was my original question? My original question had 2 to the x. And what was it supposed to equal? 3. So if I push enter and this is equal to 3, I will find out that I did it correctly. You should have left me have my numbers wrong. I would have been like, it worked, right? But it would have just been like, okay, I made a mistake. It's good because it tells you you made a stupid mistake. Well, I made a stupid mistake. It might have been fundamentally much worse than that. But you can tell right away my answer is right. Really helpful. Okay, so second question that you had on your notes. Again, don't write these down. They add some complexity. Now I have 2 times 3 to the x equals 5. So, there are sort of 2 ways of going about this. I would recommend, and it doesn't always work, in fact, my recommendation is not what I put in your notes. But my recommendation is if you can get your power, here's the power, by itself, right? If I divide both sides by 2, would that get my power by itself? Wow. If I divided both sides by 2, that would get that 3 to the x by itself. Okay? Then, I could take the log of both sides. Log of 3 to the x equals log of 2.5. This allows me to use my log law and bring it out in front. And we get log of 2.5 divided by log of 3. I'm going to test that by going to my calculator. Log of 2.5 divided by log of 3, 0.834. I'm going to find out if that answer is right. Let's store it as x. And my original question had 2 times 3 to the x, 2 bracket 3 to the exponent of x, bracket. Write it exactly as I see. If I get 5, I'll know that I've done it right. If I don't, this is where you either love logs or hate logs. You know you have to look through your question, probably start again from the beginning and do it slower. Sometimes finding your mistake takes longer than starting again and just being more careful at every step. It worked. Okay? Now, what I had in your notes is what's more typical of what students do. And I'll do this more typical method in purple. More typically, students say, hey, there's an x in the exponent. They get so excited about using logs, they do log right away. This is not wrong. In fact, sometimes the multiplication is just a tiny dot to tempt you. I'll be extra tempting right now. At this point, we often make a small mistake. Mistake number 1, some students go, 2 times 3, this is just so tempting for me. I'm going to write a 6. Not allowed to do that because order of operations say you have to do the exponent before you multiply. The next tempting mistake that students do is say, I have a log law. The log law says I can bring this x out in front. The log law looks like this. That's on your formula sheet. What you have to realize is that on the left-hand side, this exponent is to m. Our exponent is just to the 3. The exponent of x is not to the 2. So we actually have to use this log law of multiplying first, because we have a multiplying there. So multiplying says I can add the exponents. Oops. Took the log on both sides and didn't write the log on the other side. There we go. Right. So we'd add first, and now this x, I'm allowed to use that log law and bring it out in front. So I would have log of 2 plus x log of 3 equals log of 5. I want to solve for x. Here's my x. That's what I want to get by itself. Does it make sense that I can move this number over to the other side? I get x log 3 by itself by subtracting log 2 to the other side. And then I could get x by itself and so this answer looks different in form than this one did. Some of you probably recognize, hey, but subtracting logs is like dividing, so it is exactly the same. And if I type this in, I would get 0.834, just the same as the other side. The purple side is not wrong. It just has more potential for making an error. Because you have to really know your log laws well to break it up and add in first before you bring that exponent out in front. So if you can get your power by itself, it will make your life easier. However, that's not always the case that you can do that. And sometimes, as we have an example, the last example from your notes, you have x's on both sides. And I could make this even more difficult by putting numbers in front of both sides as well, to make it the most complicated solving for a log equation. Okay? This time, just for fun and for efficiency, instead of taking the log of both sides, I'm going to use the natural log. What's the difference? Technically, one letter saves you 1/8 of a millisecond of time. Very important. You're going to be so much more efficient using ln because it only has to write 2 letters instead of log, which writes 3 letters, and it's like, wow. So much time.
Time you saved by just saying that.
I know, but this is saving you time in the future as well. When we look at this question, you will see how much we actually save. Okay, so now this exponent is to the entire thing, it's allowed to come out in front. This exponent is to the entire thing, it's allowed to come in front. But because it's a big thing, it needs to come out in front with brackets. Natural log of 5 is a number. You are allowed to distribute numbers. Natural log of 3 is a number. You're allowed to distribute numbers. So I would get x natural log of 5 minus natural log of 5 equals 2x natural log of 3 plus 3 natural log of 3. I want to solve for x. I have an x there, and, well, I have an x there. So what I'm going to do is I'm going to move my terms with x's to one side of my equation. I'm going to subtract that 2x natural log of 3, and I'm going to put my numbers, I can move this natural log of 5, numbers on one side, terms with x's on the other. Once I get x's on one side, I'm going to factor it out. If I take the x out of both of those terms, I'd be left with natural log of 5 minus 2 natural log of 3. This side would stay the same. Bet you're happy about right now that we're not writing log. Look how many letters we're saving. And finally, oh yeah, you're not copying this down anyways. I'm just saving letters. I bet you I'm happy right now. Divide by this. And we're going to type that into our calculator. So, fraction button. This is where the fraction button really is handy. Oh my goodness, wow. Hey, that's cool. I don't know what I did. But 3 natural log of 3 plus natural log of 5 divided by natural log of 5 minus 2 natural log of 3. Push enter, and I'm going to store this as x. And I'm going to be very hopeful, negative 8.345. I'm really hopeful that this is right. How do I check it? Well, I've stored it as x. In my original equation, the one side was 5 to the x minus 1. So I type that in, I push enter. And the other side was 3 to the exponent of 2x plus 3. Moment of truth right now. If this is the same number as the one before, then I know I've done everything right. It's not, then I know I've made a mistake somewhere and we're gonna have to find it. So this is, nerves are getting, oh, phew. Thank goodness. So we work out these are the hardest ones where you have x's on both sides. And this factoring, a common factor of x out, is key to getting one x by itself, because then you can just divide to get your answer. So these were the three that you read over on Friday or Thursday, and probably spent all weekend just loving them and looking at them over and over again. I know you guys. But that should set us up nicely to look at our examples in our notes. Now this is not to say this is the only way to do this, but this method works no matter how complicated a question you get. Okay? There are some shortcuts that people like. That's perfect. I can even show you some. But when you see an x in the exponent, ask yourself, could you get the power by itself? Well, in the first one, the power is already by itself. Then take the log or the natural log of both sides. And that allows you to use your log law to bring that exponent out in front. I can get x by itself by dividing both sides by the natural log of 4. Go to my calculator. Natural log of 12 divided by natural log of 4. 1.792. There we go. And again, every single time, I want you to store that as x and double check, does it work? Which feels really good because you're like happy face, because you've already checked it, and you know that it's the right answer. Okay? Now, when you go on to your, sometimes if you go on to your pre-quizzes online and you click the help me solve this because you've forgotten, sometimes they introduce you to other techniques. And some other techniques are nice, sometimes even maybe a little bit faster, but they don't work in all situations. So one of the techniques that students sometimes like in this one is just taking and using the step you forget to change it, use a definition. If this is exponential form, this is log form. And if you happen to have the newest version of calculator, then you can go log base 4 of 12, get the same answer really quick. Okay? On your exam, you're not allowed to use your graphing calculator, so you might not have this button on your scientific calculator. Does anybody's scientific calculator allow them to do that? Perfect. So that's, can you see that in this case, that seems like really quick and nice, okay? But it doesn't work nicely in some of the other situations, especially in part C. So the method that I'm showing you is a method that will work no matter what kind of problem you run into. That solving for x in an exponent can be done most easily by taking the log or natural log of both sides. Okay? How many people like writing log instead of ln better? Fair. We'll do log on the next one. on the next one, first of all, here is the power. Could I get that by itself? Yes. I could divide both sides by 3, and I could get the power by itself. If you can do that, perfect. Solving for x and exponent can take the log of both sides. I think some students like to use log because it's much easier to say take the log of both sides than take the natural log of, let's see, oh, it takes so long to say. So I take the log of both sides. This exponent is to the whole thing, so now I could bring it out in front. Whenever you have a binomial and you bring it out in front, you're going to have to put it in brackets because this will need to get distributed in the next step. I want to get the x by itself, so I'm going to have to subtract the log 2 on both sides. And then I can divide. Type that all into my calculator. Log 12 minus log 2 divided by log 2. And we get 2.584. And store that as x. And double check my original equation, which was 3 bracket 2 to the power of x plus 1. It's 36. Then I'm happy. Whew. So they're solving exponential equations. The steps never change. I'm going to take the log of both sides. I'm going to use some algebra skills to get x by itself. Plus, I can check my answer to see if I'm right. So they're really nice on a test because they're usually 3 or 4 mark questions, and you'll know if you get them right. But you do have to take time to get to that. Do as many as you need to practice that you're like, I'm getting them right all the time. I think I'm ready for this. I think I've got this.
Complete the circle.
I'm okay. X is an exponent. We can't get a power by itself because its power is on both sides. So we're going to have to take the log of both sides. Sometimes people like, oh, I think I could skip right to this step. You can do that as long as you don't make a mistake, because sometimes on the final exam, just writing log in front on both sides is worth a whole mark. It's like the easiest mark you can get. You just put the word log in front of both sides, like, you know what you're doing, here's a mark. If you decide, this is actually another whole mark sometimes. Pulling the exponent out, it's a concept from grade 12. They have to give you a full mark for any new concept from grade 12. So now you're at 2 marks and you've done almost no work so far. Okay? If you skip and make a mistake, you could lose both those marks. So it's worthwhile taking the time to write log of both sides. Now I can distribute this because it's a number. I have x's in 2 terms, so I'm going to put both of my x's on the same side. So I'll have log 3 equals x log 6, and I'll move the other x log 3 over. And when you have x's in more than one term, we factor it out. Type it into our calculator. 0.631. And hopefully I made a mistake this time so we can have fun trying to find it. Store it as x. Plug it back into the original equation. So the original equation was 3 to the x plus 1. Enter. And on the... Oh, this is not looking good. Right? Now if I go to the other side... You see my mistake, eh? But we should test the other side. The other side was supposed to be what, 6 to the x? And they're not the same. They should have been the same number. So we go back. Where did we make our mistake? Where do you see?
You were supposed to, when you had x bracket log x log 6 minus log 3, you were supposed to divide log 3 by that, not that by log 3.
Oh, so it should have been like this, right? So let's try that. Hopefully we still have another mistake. Fraction by. So now it should be the log 3 on the top. Log 3. And log 6 minus log 3, right? And now I get 1.585. Oh, yeah. And store that as x. I'm going to retype in 3x plus 1. And I get 17.11. I'm going to retype in 6 to the x. They're the same. Whew. Again, it was so nice of the calculator to tell us we would made a mistake, so that we could check to find out where that mistake was. I mean, I like writing x on the left-hand side, but it caused me to mix up my numbers on the right-hand side. Would have been like,
Yeah,
can you see if you kept your x on this side, your chances of making that mistake are a little bit less?
Yeah, I kept the x on the left-hand side from very early on.
Yeah. So, either way is perfectly fine. Okay, questions for practice on this one are 7, 8, 10, and 12. And you want to do an extra hard one? The hardest that they can get? Low.
I was told Botnick was subbing for you.
He was in the morning, but not in the afternoon.
Okay.
I don't even know if this is going to work. We'll find out. Making up numbers. Oh, I don't like using 2 5s. Can I change this to a 7?
Sure, go ahead.
This being the most complicated one, you will have to write a lot of logs. So I'm going to use natural log to save us at least 3 seconds. We can't get any powers by themselves, so we have to take the log or natural log of both sides. And then because of the exponent is just to the 3, I would first have to do an adding log. And then I could bring out exponents. Once the exponent is to the whole thing, that is when you're allowed to bring it out in front. And because it's a binomial, we'll have to put it in brackets. Natural log of 3 is a number, so I could distribute it. Natural log of 7 is a number, so I could distribute it. I'll get natural log of 5 plus 2x natural log of 3 plus natural log of 3 equals natural log of 4 plus x natural log of 7 minus. Look how many letters we were saving by using natural log. I'm going to put a purple box around the x's. I only have 2 terms with x's. The rest of them are just numbers. So I'm going to keep my terms with x's on the left-hand side. So I'll subtract the x natural log of 7. And I'm going to move all of my numbers, natural log of 4 minus natural log of 7, we're already on the right-hand side. Now I'm going to subtract my natural log of 5, and I'm going to subtract my natural log of 3. Put all my numbers, even though they're funny-looking numbers, on the right-hand side. I can now factor out the x. And yes, you do have to, as annoying as it is, rewrite this whole side. And divide. Actually, I'm not very hopeful right now. Feeling, I don't know, feeling kind of nervous that I'm going to type this in and it's not quite going to match. I'm going to actually go back to this and make sure I can see it all. No. So, natural log of 4 minus natural log of 7 minus natural log of 5 minus natural log of 3 all over 2 natural log of 3 minus natural log of 7. Negative 13. Already looking unlucky that we got this right. Negative 13.002. If 13 is an unlucky number, is negative 13 like more unlucky? It feels like it should be unluckier. If that's
Isn't 002? Like that's just.
It's just like it's okay. I'm gonna store this as x and go back to my original equation, which I had written at the top. So on the left-hand side, I had 5 times 3 to the exponent of 2x plus 1. Enter. 5.87 times 10 to the negative 12. And 4 times 7 to the exponent of x minus 1. Moment of truth.
Nice.
If we had used logarithms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. We saved 34 letters, which is a about the equivalent of one full sentence in an English class.
Okay.
Which isn't very much, but a little bit.
Second.
Yes. There is a difference in that one's a base 10, one's a base E, but because of log laws and the change of base theorem, if you type this whole thing in again with log, it'll come out to the exact same number. If you type this whole thing in with log base 3,252, I don't know why you'd want to do that, but you could type in a really long equation.
You waste a lot of seconds by doing that.
Yes, you would. You will get the same number. So they're not the same, but the answers will be the same because of the change of base theorem.